Hello, today I'm recording a video for how to make an APA 7 style box plot using Google Sheets. So to get started, we have our data over here. In column A, we have our respondent ID. So this is respondent 1, 2, 3, 4, so on and so forth. This is hypothetical data. So in this next column, I have our independent variable. You would just input whatever your independent variable is. And here are the levels of the independent variable. So there are 3 levels: condition 1, condition 2, and condition 3. And then in column C, we have our dependent variable. This is what we're actually interested in assessing. We're looking at the effect of our independent variable on our dependent variable, and the values of our dependent variable are in this column. So for example, if we look at this first row, respondent 1 had condition 1 and the DV a 3. So when we want to look at the box plot, we want to look at how the DV, or dependent variable, compares across the different levels of the independent variable. In this case, we're interested in examining if there's a difference in the dependent variable based on the condition that the respondent took. So the first thing that we need to do is create 3 new columns by condition. So this means that we want to put the values for the dependent variable only when the respondent had condition 1. And then we'll do that for the other ones. So to do that, I'll just enter a formula. I'll put equal if. So if column B equals, I'm going to put it in quotes, condition 1, put column C. And you can type in the C:C, or you can just hit the row header and it'll highlight the whole thing. And then we'll add a comma and then put the other parenthesis. So if column B equals condition 1, put the value that's in column C, otherwise put nothing. So that's why I have a comma and nothing following it. So we can see here that it worked. So indeed, the value in column B is condition 1, and so it put a 3. And so we can drag and drop this all the way down. And you might notice, okay, it looks like it works. So when column B equals condition 2, it put nothing. Condition 3, nothing. Condition 1, okay, there we go, it put the value. So now we'll go ahead and do the same things with these other 2 conditions. I'm going to go ahead and add 2 $ in front of the letters. It basically holds them in place. So I can do that. It doesn't change anything, but then I can drag it over and it is still referring to the same columns. If you don't have the $, I'll take them off here, for example, and I slide this over, it slides the reference column over as well. So now this one references D and this one will reference E, right? But we want them all to refer to column C, so we'll enter those $. Okay. Here we want the values of the dependent variable for condition 2, so we need to change this argument to say condition 2. And here we need to change it to say condition 3. So now that I have the formula completed, I can just drag this down for the rest of the values. And you can go ahead and check your work and see that it inputted all of the values correctly. So I'm going to go ahead and add my values to this table right here. And this is what actually will go into our box plot. So we have the condition, the min, Q1, Q2, which is our median, Q3, and Q4, which is our max. So we can go ahead and just write a formula for this as well. So we're going to say equals quartile. We can use the quartile function. And we're going to go ahead and select column E. So we'll just put E. And what quartile do we want here? Well, we want the min, so that would be, or the minimum, so that's 0. So this function takes the argument of the column followed by the quartile. So the min here is 2. If you want to check your work, you can do equals minimum of column E and it should equal 2. Okay, so now we can go ahead and do this for the other columns. So again, we want to use the quartile function. So if I drag this down, it's still referencing column E, but now we need to change our work so that it's referencing for condition 2, column F, and for condition 3, column G. So we'll go ahead and change this to F and this to G. And I'm going to go ahead and add $signs to all of these. If I can drag it across. So I have E, 0, F, and G. I'm going to go ahead and highlight the 3 boxes. You just press down and select them. And I'm going to take this little dot, I'm going to pull it over here. So now it just copied the same formula in each of these other cells. So here we want Q1, so we'll go ahead and put a 1 there, and then we'll also edit the cells below. Here we want Q2. Q3, and Q4. Okay, so now we have our min, our max values, Q1, Q2, and Q3. So to plot it, we'll go ahead and select our highlighted in yellow. I'm actually going to unhighlight this one. But we'll still select all these and we'll go ahead and select insert chart. And then we'll select the chart type down at the bottom at the candlestick chart. So looking here, this is what it's basing the plot off of. Low, so the minimum value referencing our Q0, open, close, and high. So if you notice, it's not actually taking a median argument. So our open is going to be our first quartile. Our close, the close of the box, should be Q3, right? The median is somewhere in between Q1 and Q3. So we'll go ahead and change this to Q3. And then our high is our max value, which isn't Q3, it's Q4. So it's helpful to go through these and check them just to make sure that it's inputted correctly. I still recommend computing the median because one limitation of Boxplots in Google Sheets is that they don't have a median line, but that still is conveying important information to you about the distribution of these variables that is still worth looking at. So I went ahead and put that here so you can still look at it, but it's not physically in the graph, unfortunately. So now we can go ahead and edit this to be an APA format. So I'll just go ahead and delete this title. And then I'm going to go ahead and remove these grid lines. So I selected them. I just went over with my mouse until they're highlighted, selected them, and it brings up the box here with major grid lines, and I'm just going to uncheck it. And then I'm going to go ahead and under vertical axis, I will add major ticks, which added the tick marks for each value. And it also added an axis, which is nice. I'm going to position them on the outside and make them a little shorter. And I'm going to switch the vertical axis. Let's do the horizontal axis. We'll do the same thing here, add major ticks on the outside, make them a little bit shorter. And now we can go ahead and add our axes titles. So these are the axes labels. They look good. So it's just taking whatever information I put here. So if I change this to be like C1, it updates in the plot automatically. But to change the label on our x-axis, I can select it, or you can go to the chart and axes titles and select horizontal axis title. I'm going to go ahead and input the title and just put independent variable. In your case, it would be whatever the name of your actual variable is, and then go ahead and bold it. Now we can go to our vertical axis. I'm going to add dependent variable. In your case, you can just put whatever your dependent variable actually is. So is it response time? Is it questions answered correctly? Whatever it might be, and go ahead and bold it. And just like that, we have our APA 7 styled box plot. So now you would just input it into the document that you're working in to add the figure number, the figure title, and then the note. But we will not do that in this in Google Sheets itself. One thing again, so there is no median line in these plots. And also there might be outliers in here. Google Sheets does not add dots for suspected outlier values. It looks at Q4 as a max value and it just extends the line to the max. So you still have to go through and look at if relevant to your research question and problem, and you are interested in looking at outliers, you do still, this perhaps is not the best visualization for that. I show an example here. So for example, if I wanted to look at the outliers using a interquartile range method where I say, oh, perhaps I will define an outlier as a value that is greater than or less than 1.5 times my interquartile range above or below the third and first quartiles respectively, I can go ahead and compute that. So I can start by computing the interquartile range, which is just Q1 subtracted from Q3. And I did that for each of the conditions here. I multiplied that value by 1.5, and then I either subtracted it from the first quartile or I added it to the third quartile. So for example, this value here says that essentially I could consider whatever is above 15.5 as an outlier, if this is my criterion. Of course, there are many other ways to detect and examine outliers. This is just a simple example, but of course your outlier method should be well-defined and specified and should be supported in the context of whatever you're doing. Thoughtfully applied, I guess, is the best way to put it. Here, negative values just suggest that, the minimum, I know that the minimums are positive numbers, whole numbers above 0. So we're all good on the lower end, but there might be some outliers here on the upper bounds. Just something to consider. Well, thank you so much for watching, and I'll see you next time.